Well, welcome to the randomizer. It's 6 p.m. Eastern Standard Time, and I'm your host, Charles Schultz. And tonight's randomizer is about PET scanners. So we're going to look at the term, see what it means, and where it came from. And we're going to get a little bit of an education about antimatter along the way, because believe it or not, PET scanners use antimatter, but in an unconventional way, not what you would expect. So I always promote our site. It's growing, and it's because of people who spend their time becoming a member and supporting our meetings and our classes, and I truly appreciate that. Go to schultzlaboratories.com or universesciencecenter.com, click on the links and come through to our randomizer. Of course, that's free every weeknight at 6 p.m. Eastern Standard Time, or join our classes, which are 9 p.m. Mondays Eastern Standard Time, or become a member of Schultz Laboratories or Universe Science Center and support the growth of our galleries. Get a free education out of that. Really, basically, there's so much in there, and it's growing every day. We're adding more all the time. Put your Oculus on, walk through, get familiar with the galleries and the exhibits, play around with things. It's great fun. Share it with the kids and show it to other people. We appreciate that, and word of mouth is one of our strongest forces for advertising what we're doing and getting more members. We appreciate that for everybody. Okay, so tonight, PET scanner, what's it all about? A lot of times you'll go to the doctor and they want to see an image of what's going on inside the body. Now, x-rays, as most people know, constitute a little bit of a radiation hazard, and the more x-rays you have, the more exposure you have, and it's not something that goes away. Exposure to radiation can be cumulative, which means it builds up over time. And so even a small x-ray, even though they're very good at making an image these days with very little energy, it can still add up and cause problems over time. So you want to do full body imaging in great detail without that sort of a hazard. So they'll often do a PET scan. So what is a PET scan? PET is an acronym, and it means positron emission tomography. So there are a couple of things we need to unpack there. First of all, tomography. What is tomography? Well, that actually comes from a Greek word, tomos, which means to slice or to cut into. And tomos is actually the same root word for atom. Atomos means indivisible or unable to be cut up. And so Democritus, the Greek philosopher and scientist who came up with the term atomos for atoms, was the fellow who developed atomic theory. But when we talk about tomographs, we're taking slices through the body. So what's doing the slicing? Actually, a PET scanner has a ring. It doesn't have the giant magnets like an MRI does. What it has instead is a large ring that goes around the body, and it has sensors inside called scintillation detectors. A scintillation is a brilliant tiny flash. And so when something sparkles, some people say it scintillates. Well, a scintillator or scintillation detector is actually a material that when a particle of radiation goes through it, it will convert it to a flash of light known as Cherenkov radiation, a blue-white flash. So they have actually very simple materials such as certain types of plexiglass or lucite that show up scintillations when exposed to radiation. The problem is they're so faint and so tiny that the human eye generally will not be able to see them. So they put a very sensitive photo detector against the piece of plastic, and they wrap them in utterly black, light-proof material. And they make clusters of these sensors, and they put them in a ring around the body. And they're hooked to a computer to gather the data. So now, when a source of radiation such as gamma radiation is detected, the flashes of light that are picked up can be reverse calculated to see where the point of light came from. And by doing this for millions of samples, the slice through the body is made. So where the ring is positioned over the body, you've got a slice through the body. And as the ring is moved forward, it's taking numerous little slice images through the body, and then the computer knits them all together to make a solid image of your whole body. So that's what a PET scan is. So now, what's the positron part? Well, anyone who studies physics, particularly particle physics, understands that a positron is a particle that's very much like an electron. It is the cousin, or I should say it's the twin brother of the electron, except it is reversed, mirror reversed in every way. Instead of a negative charge, a positron has a positive charge. Instead of spinning one-handed, it spins the opposite hand. Every property of an electron reversed would give you a positron. So what does it mean? What it means is a positron is literally antimatter. So antimatter is similar to normal matter, but as suggested, everything about it is a mirror image. The spin, the charge, everything. So where does this antimatter come from, and how do you get it in a PET scan? Well, this is the most interesting part. There are many elements that naturally decay and give off positrons through a process called beta decay. Now, beta decay can go two ways. It can end up emitting an electron, or it can end up emitting a positron, and it's about 50-50. Some decay paths are a little more leaning toward the electron, and some a little more toward the positron. So here's what they do. They take a sugar, such as glucose, and they tag it with some element that breaks down through beta decay and gives off the positron. So now before you take a PET scan, they'll give you an injection of this glucose, this tagged glucose. Why glucose? It's because that's the fuel that powers cells and metabolism. So when the glucose enters your bloodstream, certain cells that are metabolizing more than others will take up more of the glucose. And being used by the cell, the products of the metabolism, breaking down the glucose and oxidizing it, remain in the cell or in the bloodstream near the cell. This is where the breakdown occurs. The cells that are eating more fuel, using more glucose, will have more of that positron-emitting chemical near them or in them. So the end result is you tag a fuel or food, it's injected into the body, and the PET scanner detects the radiation given off by the positrons emitted from these cells. Now, they're not detecting the positrons, but they're detecting something else. As I said, positrons are antimatter, and there's an interesting property. When antimatter and normal matter come together, they utterly destroy each other, they annihilate each other, and the result is gamma radiation, tiny bursts of energetic gamma rays. For electrons and positrons, there's only two specific flavors or frequencies of gamma ray that are emitted. 0.51 MeV or 0.34 MeV. And so these two signatures are very distinct, just like two colors of light that are very distinct. And the detector picks up these frequencies, these gamma rays, pinpoints back where they came from and reconstructs the image of the body from where those positrons are being emitted. Now the positrons fall apart by colliding with normal matter, and there are two reactions that occur. One, a positron, being positively charged, will draw in an electron which is negatively charged. They will collide and go up in a flash. Two, there's another way this happens, and it's kind of an exotic reaction. Sometimes a free electron and a positron will approach each other, but they won't collide instantly. They will fall into a spiral around each other, orbiting closer and closer and faster as they zoom in toward each other, and they're giving off photons the whole time they're spinning in. This exotic form of matter that only exists for a very short period of time, about 20 nanoseconds, this form of matter is called positronium. And so it is truly an exotic compound of a piece of antimatter and a piece of normal matter, an electron and a positron. And in this 20 nanosecond period, that's 20 billionths of a second, in that time, they spiral in, give off a burst of radiation, and then when they collide, they give off the gamma rays. And this is what the sensor picks up. So these two reactions are the thumbprint of the emitted positrons, thus positron emission tomography. So the positrons are emitted, they react with electrons, they give off gamma rays, and the sensor sees the gamma ray signature, that light. So this is what a PET scan is all about. Is it harmful? You know, the thing about it is, your body does have a natural defense to radiation damage, and it can usually repair or stop the wildfire. It will do enough to keep you functioning properly. So, in the sum of things, you're always exposed to some form of radiation naturally in the world around you anyway. I ran into an interesting conversation with somebody recently who thought that radiation was something that just we made, humans made. And I had to explain, no, radiation has been around since the very beginning of the universe. And even the food, your air, the products around you, all of them radiate something. If you live in a house with granite countertops, the granite is giving off particles from natural radioactive decay, mostly from thorium and uranium and other compounds that exist in the mineral granite. What's interesting is many people are familiar with Grand Central Station in New York City. Grand Central Station is made almost entirely of granite inside. As a consequence, the radiation background count inside Grand Central Station is 10 times higher than what is allowed in the control room of a nuclear power plant. And most people aren't aware of that. Here's another interesting fact about natural radiation. A coal-fired power plant puts 10 times more radiation in the environment for every kilowatt of power produced than a nuclear power plant does. And do you know why? It is because when you're burning the coal, the mineral composition of the coal always contains things other than carbon. And some of the elements that are contained in the coal, in the exhaust, in the dust, are radioactive elements that decay. So burning coal is 10 times more radiation in the environment for every watt of power you generate than running a nuclear power plant. And that's an amazing fact that almost nobody is aware of unless they work in the industry. So there are two strange things. The most radioactive foods, banana has potassium 40. Banana is anything with potassium, and it puts potassium in your body. And you can't help it, you've got to have it to live. Some of it just breaks down naturally. The air around you contains different isotopes of oxygen and hydrogen and nitrogen, and some of them are radioactive. And it's just a natural consequence of the fact that cosmic radiation coming from space is colliding with atoms in the air all the time, and it's activating some of them. So there are elements in the air, the water, the ground, your food, and in your body itself that are radioactive, but only at a very low level. For the most part, your bodies are well able to take care of any sorts of damage by repairing the genetic damage. That's why the chromosomes have so many copies and the cells have so many copies. And one interesting thing, when you open a gene inside of a chromosome for replication, the right and the left half are like mirror images of each other that fit together a certain way. When damage occurs, the cell usually can sense that and repair it by looking at the reference half or doing other simple processes. So cells have repairs, and you may have cancer 6 to 12 times throughout the period of your life, and the body will fix it. It's only when it doesn't that it becomes an issue. So, positron emission tomography. I hope that kind of clears up what it's all about. And, you know, at the technical end, it's very similar in a way to magnetic resonance imaging, which also measures slices through the body excited by radio waves by making the nucleus of an atom spin a certain way. But that's another story. So, if anybody has any questions about PET scanners or science in general, the floor is open. And in the meantime, I'm going to encourage you to go to schultzlaboratories.com or universesciencecenter.com, sign up for our classes, sign up as a member, do something to support the efforts that we're making, and tour through our Universe Science Center. Go through the virtual galleries, have fun with it, play with the things, share it with your friends. So from here, the floor is open again. I see no questions so far, and if I don't see it in the next few seconds, I'm probably going to call it this is a success. And I have one more thing to say, and it's a quotation from Hebrews 13:16. And do not forget to do good and share with others, For with such sacrifices God is pleased. What a wonderful thought. Help your neighbors, help a stranger. Don't make a big deal of it. Don't do this when you're helping people. It totally destroys the spirit of the event. The best charity is done in private and unknown. Just make the world better. My favorite statement. Make the world a better place. Well, everybody have a wonderful evening. I hope you've enjoyed the explanation. Tune in tomorrow at 6 p.m. Eastern Standard Time for another randomizer, another randomly chosen subject. And with that, have a good night to everybody. Take care of yourselves.